Okay, this is the first part of the Guywire problem, which is, I think, part of activity 3. You can see here that there's a 3D model which I have put into a true shape view so that you can see actual lengths over here, and there's some things to do and some information from the engineer. Okay, so let's open that up a little bit. And then the other thing that you see over here is where you're going to actually do your problem solving. But let's take a look at this. From the true shape view, we can get true distances and true angles and more true distances. And the engineer then has come up with some important information. FDW, that's the distributed force of the wind. It's pounds per inch of height as the wind is blowing against it. There's either going to be 5, which is in a low, get a heavier wind, 7 to 5, and the maximum is going to be 10 pounds per inch. And of course, the thing is 100 foot tall. So that's actually a lot of force when we get down to it. Then there are some relations that are based on this geometry over here. This height, this angle, this angle. So those all come into a set of relations that we can figure out here. And so then the engineer has told us that we can look at this formulation from a certain spreadsheet. Okay, and this is linked to that spreadsheet. We can go, well, that one's an image of the spreadsheet. Okay, so I've got the spreadsheet set up here. Here is the spreadsheet itself where this image is coming from. Okay, and we're going to use this spreadsheet to find the maximum load in each cable, the minimum cable size, quarter-inch cable, half-inch, 1-inch, how thick, what diameter cable do we need, and the appropriate WLL. And we have to figure out what that means. Okay, and an eye bolt size and size of the anchor bolt pad. In other words, we're going to solve some problems based on this geometry to get the design done and get it done right. So this says there's force due to the wind, force in the cable, F1, and force in the cable, F2. Okay, and we have 3 different versions for it to make. Right, so there we go. That's all what we're looking at here. So I can make this full size now, and I'm going to make it a little bit bigger so it's easier for you to see. And we're going to do this first thing. We want to find these loads based on this information. Well, the engineer set up a spreadsheet for us. We don't have to do that. The engineer has given us our first calculation spreadsheet and said if this is the linear force, then this is going to be whatever shows up in B8, 5 times 12 times 100. That 12 times 100 is turning feet to inches. So that's my force of the wind. And then he's given me these. Now, it's very cool. You don't have to type these in again. You see this little, it's hard to see, but there's an apostrophe right there. Okay, so I want to get rid of that apostrophe. But let's see how these got done this way. If I go to the view, I can show formulas, or I can turn that off. So if I get rid of the apostrophe. Get rid of the apostrophe because that says it's not a formula but just some text that I typed in. So I'm going to get rid of the apostrophe on each one of those and turn it into an actual equation. So I've just done that. I've turned each of those into an actual equation. And when I go to my view show, if I turn off the formulas, it shows me the answers. That is so cool. That is so cool. And I'm going to take all of these ones and, we just need to know to the nearest pound. And these are all pounds now. So when the wind is blowing at 5 pounds per inch along it, I've got 6,000 pounds actually trying to push that tower over. Okay, and I've got 2,500 pounds tension in that cable and 2,200 in my other cable. But I said I want to use my highest wind. So this is the one we're going to work with right there. So there's your very first thing to do. Wire tension computation. And you're going to find that this is how some engineers communicate with you. They put an apostrophe in front of this so that you know what the calculation is, and then you change it from just a bunch of letters to a calculation. And you can view it either way. View formulas or view not formulas. So that's kind of cool, isn't it? That's really, really nice. And I have it set up right now so I'm not seeing the grid lines. Actually, it does show I'm seeing the grid lines. There we go. Now the grid lines. I must have made the grid lines white. So you can turn those off. So you can see the formulas or not. You can see the grid lines or not. So that's our first thing to do, is find the wire tensions that we've got to work with. Okay, there we go. That's step one.